The navigators on airplanes and ships often need to know the angle or bearing at which the plane or ship must traverse to stay on course, and they use the inverse trig functions to find such angles. In doing so, they also need to know the derivatives of the inverse trig functions. Hi, my name is Jason Rosenberry, and that's what we will be examining in today's lesson. Let's start with a theorem that establishes the conditions under which a function has an inverse function. Theorem 3. Derivatives of inverse functions. If f is differentiable at every point of an interval I, and if df dx is never 0 on I, then f has an inverse, and f inverse is differentiable at every point of the interval f of I. With these conditions in mind, we are ready to review the arcsine function and find its derivative. We know that the function x equals sine y is differentiable on the interval negative pi over 2 to pi over 2, non-inclusive, and that its derivative, the cosine, is positive there. The theorem therefore assures us that the inverse of this function is differentiable. So let's find its derivative. Let's say we're trying to find dy dx, where y is equal to the inverse sine of x. And let's rewrite this equation such that y equals inverse sine x is the same thing as saying that the sine of y is x. And now, using implicit differentiation, let's differentiate both sides of this equation with respect to x. So on the left-hand side, dy dx of sine y would be equal to cosine y, but then the chain rule kicks in and we would have times dy dx. Over on the right-hand side, derivative of x with respect to x is just 1. Solving for dy dx, we have dy dx is now equal to 1 over cosine y. Let's make some substitutions. We have dy dx equal to 1 over cosine y is the same thing as the square root of 1 minus sine y squared. And what again is sine y equal to? Right here it tells us sine y is equal to x. So we have dy dx equal to 1 over the square root of 1 minus x squared. The formulas for the derivative of the arctangent and the arcsecant are derived in a similar way. Let's take a look at all of these formulas summarized. The derivative of the arcsine. If y is equal to the inverse sine of x, or the arcsine of x, then dy dx equals 1 over the square root of 1 minus x squared. Derivative of the arctangent. If y is equal to the arctangent of x, then dy dx is equal to 1 over 1 plus x squared. Derivative of the arcsecant. If y is equal to the arcsecant of x, then dy dx is equal to 1 over the absolute value of x times the square root of x squared minus 1. Let's try an example. Find the derivative of y with respect to the appropriate variable. Here we have y equals x times the inverse sine of x, or arcsine of x, plus the square root of 1 minus x squared. So here we go. Let's find dy dx. So we see that we have two terms, first term, second term, so we'll take the derivative of each term. The first term, we see we have a product, so we need to use the product rule. So that would be first function, x, times the derivative of the second function, and the derivative of inverse sine is 1 over square root of 1 minus x squared. So there's first times derivative of the second, plus the second function, inverse sine x, times derivative of the first function, and the derivative of x is just 1, plus the derivative of the second term. So we have 1 minus x squared, all of that to the 1/2 power. So that derivative would be 1/2 times 1 minus x squared to the negative 1/2. And then chain rule says we have to go back and take derivative of what's in the radical, which would be a negative 2x. So let's simplify what we have. We have dy dx equals x over the square root of 1 minus x squared. There we just multiplied those two together. Plus we have inverse sine or arc sine of x, plus, actually minus because of this negative sign. We have 1/2 times 2, that makes a 1. So it looks like we have x over the 1 minus x squared to the negative 1/2 would flip that radical to the denominator and make it the square root of 1 minus x squared. And looky here, we have two terms that cancel out. We have a positive x over root 1 minus x squared and a negative x over root 1 minus x squared. So these two terms cancel out, and we're left with the arc sine of x. So dy dx is equal to the arc sine of x. And let's try another example. Find the derivative of y with respect to the appropriate variable. Here we have y equals the inverse secant or arcsecant of 5x to the 4th. So dy dx would equal 1 over the absolute value of 5x to the 4th times the square root of 5x to the 4th squared, which would be 25x to the 8th minus 1. Now also, the chain rule kicks in and we have to take the derivative of what's in the parentheses. So times 20x cubed. And now we can simplify a little bit. We have dy dx equals, and in the numerator we can put the 20x cubed. And due to the fact that 5x to the 4th will always be a positive amount, we can drop the absolute value. So that's 5x to the 4th times the square root of 25x to the 8th minus 1. And we can cancel out some common factors, and we're left with 4 over x times the square root of 25x to the 8th minus 1. To find the derivatives of the other three inverse trig functions, we use inverse cofunction identities. Let's take a look at those. Inverse cofunction identities turns out that the arc cosine of x is the same thing as pi over 2 minus the arc sine of x. Arc cotangent of x is pi over 2 minus arctangent x, and arc cosecant of x is pi over 2 minus the arcsecant of x. These are the three that we want derivatives of. So notice, by taking the derivative of both sides of these equations, the pi over 2 is treated as a constant, so that would go to 0. So the derivative of arc cosine will equal the opposite of the derivative of arc sine, which is true for all three of these. So the three that we need derivatives of are simply the opposites of the three derivatives that we just derived. Let's try an example. Find the derivative of y with respect to the appropriate variable. We're given y is equal to the arctangent of the square root of x squared minus 1 plus the arc cosecant of x, and we're told that x is greater than 1. So here's y, and we're also told that x is greater than 1. So let's find dy dx. And we see that we have two terms, so we'll find the derivative of each term. So let's go with the first term. The derivative of arctan root x squared minus 1 would equal 1 over 1 plus u squared, where u is the radical. So it's 1 plus the square root of x squared minus 1 squared. Now chain rule kicks in. We have to take the derivative of u. Derivative of square root of x squared minus 1. So this is times 1/2 times the quantity x squared minus 1 to the negative 1/2. Chain rule kicks in again. We have to take the derivative of x squared minus 1, which is 2x, plus the derivative of arc cosecant x, which is negative. So that negative with our positive here makes this now negative. 1 over absolute value of x, but we're told that x is greater than 1. So the absolute value of x, we can just write x times the square root of x squared minus 1. So we got some simplifying to do. The first fraction, the 1 over 1 plus quantity root x squared minus 1 squared, that becomes 1 over 1 plus x squared minus 1 times, here we have 1/2 times 2, that makes 1. We have this factor of x that we can write in the numerator, and the quantity x squared minus 1 to the negative 1/2 we can kick to the denominator and write in radical form as the square root of x squared minus 1. And then we have minus 1 over x times the square root of x squared minus 1. So now let's see what happens when we put these two fractions together. Notice the denominator of our first fraction, the 1 and the minus 1, cancel out, and we have this factor of x divide out this factor, or a factor of x. So we put those first two terms together with multiplication, we end up with 1 over x times the square root of x squared minus 1 minus 1 over x times the square root of x squared minus 1. So this all ends up being 0. Now it's time for you to try a problem. Find the derivative of y with respect to the appropriate variable. We're given y equals the arc cotangent of square root of t minus 1. Pause the video while you work on this problem. When you are finished, restart the video and check your solution. So here we go. Let's find dy dt. So the derivative of arc cotangent square root of t minus 1 is the opposite of 1 over 1 plus the function squared, or u squared. So this would be the quantity or square root of t minus 1, all of that squared. But now again the chain rule kicks in and we have to take the derivative of this part. So that derivative would be 1/2 times the quantity t minus 1 to the negative 1/2, and then again times the derivative of this expression under the radical, but that just ends up being a factor of 1. Now it's time to simplify. So we have negative 1 over 1 plus t minus 1 times, second fraction we can write as 1 over 2 times the square root of t minus 1. So simplifying the first fraction, the 1 and the minus 1 make 0, leaving us with a negative 1 over t, and we're going to multiply that by 1 over 2 times the square root of t minus 1, giving us a final answer of negative 1 over 2t times the square root of t minus 1. In this lesson we explored the derivatives of the inverse trig functions. Be sure to work the exercises that your teacher assigns, and we'll see you next time.